This is a question from Class 12 CBSE sample question paper. Look at this question. So there is a story part in this question. So do not read the story part. Look at where the question starts. It starts here. The cost of the production and the revenue function. So this is the cost function and this is the revenue function. The cost function depends on X, where X denotes the number of units either sold or produced. So X is number of units sold or produced. If it is cost function, then it is units produced. If it is revenue function, then it is X is the number of units sold. Okay. So I'm skipping this part. Okay. So now look at one more question, one more part in this question. So which is this is the cost of the production. So which means you look for information such as cost per unit, or is it just the cost? If they have given just the cost, it means the total cost. So what happens if they have given you cost per unit? So which means you will multiply the cost per unit into the number of units produced. So that will give you the cost per unit into X. But in this question, they have not mentioned it as the cost per unit. So it should be just the cost of production. That is C of X, and this is revenue function where C and R are both in terms of rupees. We'll look at the questions here. To maximize the profit, the company needs to analyze. Okay. To maximize the profit, the company needs to analyze the functions using calculus. So derive the profit function P of X. P of X would be equal to revenue. So in general, profit is what? Selling price minus cost price. In this question also, profit P of X is the revenue function minus the cost function. So that will be minus 0.3 x square plus 20x minus cost function would be 0.5 x square minus 10x plus 150. If you bring this minus inside, it becomes minus 0.3 minus 0.5 x square. So it becomes minus 0.8 x square. 20x plus 10x becomes 30x minus 150. This is the profit function they have asked us to derive, and we have done that. We'll move on to the second question. Find the critical points of P of X. In order to do this, we need to find P dash of X and equate it to 0. So that would be minus 1.6x plus 30 is equal to 0. So 1.6x is equal to 30. X is equal to 300 divided by 16. If you calculate it, it becomes 75 divided by 18. X is equal to 18.75. And since it is just a linear function, we have only one critical point. There are not many critical points. There is just one exact critical point, which is 18.75. For the third subdivision A question, determine whether the critical points correspond to a maximum or a minimum using the second derivative test. So in this question, we need to find what is P double dash of X. So what was P dash of X? That was minus 1.6x plus 30. That is P dash of X. If you double differentiate it, you get just this minus 1.6, which is a negative value. So what does this second derivative test say? If f double dash of x gives you a negative value for any particular critical point, then at that critical point, the f of x would be maximum. Likewise, if f double dash of x is positive, then f of x would be minimum at that critical point. So here p double dash of x is negative. So at x, the critical point that we found at x is equal to 18.75, the the profit would be maximum. We achieve maximum profit at this critical point. So they're not asking us to find the maximum profit. They're just asking us to determine whether the critical points correspond to a maximum or minimum. So we just have to use this second derivative test and say that at x is equal to 18.75, the profit we obtain is maximum. Third question, B subdivision. So here is a tricky part in this question, because they've asked us to use a practical value of x. If you read this question carefully, they're asking us to identify the possible practical value of x, which means the x that we obtained, 18.75, which was the critical point, that is not practically possible, because x here denotes the number of bulbs either produced or sold, and x cannot be decimal or a fraction. So they're asking us to find a practical possible value of x, and they've given certain limitations on x. The resources available and the expenditure on machines allows us to produce a minimum of 10 but not more than 18 bulbs per hour. So that would mean here x can range from 10 to x can be from 10 to 18, so which means we cannot exceed 18, so x has to be a maximum of 18. So this is a quadratic function. If you remember, the profit function was a quadratic function. So a quadratic function can give you a parabola which is either upward facing or a downward facing. This is a downward facing parabola. That is because it is its x square coefficient is negative. So in this case, the parabola is going to be facing downwards, and this particular peak point of the parabola here, that x particular, I mean at this point the x would be equal to 18.75. So this is where the profit p of x is maximized. Okay, so when it is 18, x is equal to 18, we still get a high value of profit, but that would not be the maximum. But going by this question, we cannot go beyond 18. Okay, and so all the other lower values, say starting from 10 till 18, all the other values will give you a profit value which are all lesser than when x is equal to 18. And if x was able to be 18.75, then the profit would have been maximized. But this profit is not practically possible. That is because x cannot be practically 18.75. So x can only be practically the highest possible practical value of x can only be 18. So we stop at x is equal to 18, and the corresponding profit when x is equal to 18 would be minus 0.8 into x square. That would be minus zero point 0.8 into 18 square plus 30 into 18 minus 150. So that would be minus 0.8 into 18 square is 324 plus 540 minus 150. So 540 minus 150 is 390 minus zero point 0.8 into 324. So that would be 8 into 4 is 2, and hey, so this would be 9, 1 carried over, 2592. So 25 point, 259.2 minus. So 390 minus 259.2, so that would be 131.8. Or rather, is it 130.8 rupees? So the maximum practical profit is 130.8. So we have answered all the four questions in this question. We'll meet in another session.